up with. Anything we need to go over from the other sections that we did the other day? I know Adrian had one he sent me and I wasn't able to. Did you get that at all? Adrian, the one I sent you? Okay, so let's take a look at that variety. Let me get this out of the way. And it was one that had 1/17 parentheses log 6x plus 5 log 6y equals x. I think that's kind of like what it was. Is that similar? I know it's not the exact same problem, but it's similar to it. And what we need to do with this one, of course, we need to put it all back together again on this side. And so we get 1/17 log 6xy to the 5th equals x. The 17 in here means that this whole section is going to have the root of 17. So it's going to be log 6, the 17th root of xy to the 5th is going to be equal. I don't think they had an x at the end of it. I think we just need to put it back together. I don't think it had anything it was equal to with that one. But it's this root thing that ended up causing the problem in there. Because like, what in the world do I do with it? But you got to break it back apart, put it back in as it was. So you got a plus, which means they're both multiplications. So then we time back together. The 5 out here in front of the log 6 means that y needs to be raised to the 5th power in order to have that thing work out. So that's what we need to do with those. Okay? That make better sense? Okay. I think Rose, you and I sat and worked on that one for a while the other day. Did it? Yeah. Okay. Good. So that's the kind of the tricky one, and that was in 11.5, I think, was where that one was at. And so it is the little trickiness to that one. Or no, maybe it was 11.5 because 11.6 was where you had to figure out your actual answers to that using your calculator. Anything else in this chapter so far that we need to take a look at? Anything else that we need to do? Okay, so today we're down to the very last section, and that last section is 11.7, and it has a bit of stuff in it. So it's going to pull back the stuff that we've worked on in chapter 11, and so we're going to do some more stuff with it. In this case, it's logarithms and exponential equations and change of base. And so change of base means that we have to work with a log because our bases are not going to end up matching in there for those. So our objectives: to solve exponential equations in which the bases are the same, and we've did this. We worked on this, I think it was back in 11.4, I think, was where we did that at. So we're going to pull that back and take another little review of it. We're going to solve exponential equations where the bases are not the same, and we're going to use logs or natural logs to do that. You can choose whichever one because they both work out exactly the same. And then solve equations with logarithms, so those are going to have it in it. And then finally use the change of base formula and a calculator to equate the logarithmic expressions. So that's our goal for today, what we're going to get done in this section. So one thing they did is to go back and review all of our property rules. We've had these for quite a while. Had them back in basic math. They were in 5.1 and 5.2. That was your extra credit a while back, where we had to go through and get those back in line because we used them in chapter 9 when we worked with bases that had fractional exponents. And so we worked with them just this semester. So hopefully they're fresh. B to the 0 power is equal to 1. These two is a subtraction because it's a division and your bases match. This one's a distribution because I'm just giving everything an x. This one, because it's a negative, means it goes to the denominator. And that one also reverses because if it were in the denominator, it would come up to the top. And so it would move to the top. B and to the x and b to the y is an addition. And then this is a distribution. And then finally the last one is also a distribution. Now, will we use all these today? No. They're just there to make sure that you reviewed it and so you had a good idea of what was going on with your exponential bases and stuff. These we have had throughout the section. They are on your sheet that I handed out the other day, that single page sheet. These are our rules or our properties that go along with logarithms. B has to be bigger than 0 and B cannot equal 1, and we know that. And then here, b to the x, b to the y, we know, and we've known that since chapter 10, that these two are equal to each other. So if our bases match, the exponents are equal. That's an important thing for today because we're going to get into using that. And then if x and y are equal to each other, then b to the x and b to the y are equal to each other. Notice the same bases. So we got bases in there. Log bx and log by, then x and y are equal to each other. So if I've got the same log with the same exponential value in here, we're good. And so y's and x's will equal each other. And then last, if we have x and y, we can attach them to logs, and we're going to do this a bit today. And that might be a new one that we haven't had before. So those are our rules, and those are the things that we end up, of course, following with this. So in this problem, things change a little. Our bases are the same, and so our math gets to be a little bit more difficult to do, mainly because our bases match. Since our rules tells us if the bases are the same, the exponents are equal to each other. So x squared minus 7 is equal to 6x. Subtract 6x, because we need to solve these. So again, a good review of factoring comes out because we have to be able to factor this one to get our answers. So again, we're going back to taking a look at some of the stuff we've done in here. So we factored stuff in chapter 7. So what does this factor to? What would we get? Negative 7 and a plus 1. Perfect. And so then I set each equal to 0. And I find that x could be 7 or x could be a negative 1. And in both cases, if I plug those back in here, they're going to make my problem work out correctly. So if I plug them back in, I'm good to go. Okay? So 7 went in here, 49 minus 7. Then 7 times 6 is 42, and sure enough, 49 minus 7 is 42. And then a negative 1 squared is 1. 1 minus 7 is a negative 6. And a negative 1 times 6 is also a negative 6, so we know we did it right. So it ends up working out correctly with that one. So we did this. This was, again, 11 fours type of stuff, and so we've worked with that part before. We've also did these. When you first look at it, we're looking at 8 raised to the 4 minus 2x power and 4 raised to the x plus 2 power. But we can force these things to become like bases in here because 8 is 2 to the 3rd power. 4 is 2 to the 2nd power. And so then what we would have is our bases now match. So we have 3 times 4 minus 2x is equal to 2 times x plus 2. And we can go from there and figure out what x would be. So always look to see if you can make it have like bases. So if you can make it have like bases, we are good to go. But if you can't make it have like bases, then we're not so good to go. with this. So finishing it, 3 times 4 is 12. 3 times the negative 2x is 6x. 2 times x is 2x. 2 times 2 is 4. Get all my stuff together. So I'm going to add 6x. I'm going to take away a 4. 6 plus 2 is 8x. Divide by 8 both sides. And we find out that our x value is equal to 1. So we end up getting 1 out of that. And so that becomes what our solution would end up being when we're working with that. So if we have like bases, we're good to go. So in that case, since we're good to go with that part, we can continue on with that. And so do you think you're okay with this part, with that one? Or do you think we need to go and go back and do another one like it? You good? Okay. So if we're good with that one, then that's where we'll stay, and we won't end up doing an additional one in there of those. So then we move on. That was the first one of solving things that have like exponential bases. So our base is the same, so we just set our exponents equal to each other. This one, it says solve each of the following exponential equations by taking the log or ln. We can use natural logs or we can use logs. Either one, it doesn't make a difference. Of both sides, or using the definition of logarithms as an exponent. So we're going to take this piece, which is 10 raised to the 3x minus 2, or equals 2.1. And first we're going to make and take and put a log to both sides. And then use the definition of logarithms for exponential as follows. So let's take a look at that. We're going to have 10x, 10 raised to the 3x is equal to 2.1. So if I take this and I make each side a log, notice I can never ever get these bases to match. They never will match. So if I put a log on each side, then use my rules that the 3x needs to come out in front, because if we're going to solve that, we need to do that. Then to get 3x by itself, if I divide off log 10, are we good so far? Again, what happened here is the bases did not match. So because they did not match, we needed to come up with another way to solve it. So these log 10s cancel. And on this side, I have log 2.1 divided by log 10. So I can just stick that on my calculator and work it out. So does it work out? So let's figure out what we get. So if we can get it to come out, so we're going to go log 2.1 divided by, I gotta go back here and put my parentheses in. This is where it really is important you put your parentheses in, because if I did divided by log, it would have still taken the log, but it would have taken 2.1, divided it by the other log. So I want to make sure that when I do that, I close that in a parenthesis. And I get that for my answer. So currently, I have 3x is equal to 0.322219297, long old thing in there. But if you leave that on your calculator, and the only reason I wrote that out here is because I knew what it would be. But to get x by itself, I need to now take that answer on my calculator and divide it by 3. Then I'm going to get what I need. And I think in your Hawk stuff, it says to round to the 5 decimal places, maybe. If it's 4, you can do that too. So we're going to round this thing to 5 decimal places. The 8, the 6 is going to, or the 0, the 6 is going to make it become a 1. And so that is the value that x happens to equal. All right. So we can do it that way. Now the other thing about these is if you don't like using logs, you can use natural logs. So it really doesn't make, and let's do it that way with using the natural log and see what we come up with for our answer to this one. So I'm going to go ln 10 to the 3x is equal to ln 2.1. Put my 3x out in front. Divide by ln 10. These cancel. So if I put that on my calculator, what will I end up with? So if I go natural log 10, or no, 2.1, parenthesis, divided by natural log 10, parenthesis, I get that. And is that the same thing I had over here? Notice it's exactly the same. Okay, so then if I divide that by 3, I will find out that x is equal to 0.17 or 10741, which is exactly the same answer. So whether you use natural logs or you use logs, you're good to go. Okay, so this is if the bases did not match. So we got to be careful and watch for those when they don't match in there. Okay, good so far, do you think? Okay, and then we've got this one. This one again, they do not match. So we can do the exact same thing with this one. We can go log 6x equals log 18. Put my x out in front. Divide by log 6. And these cancel. So we're going to find out x is equal to log 6 divided by log 16. I get my 16 in there. Divided by log 6. Is it 18? Oh, it is 18. Thank you. Well, I'm going to go back and fix that then. Put 8 in there. And now, I think I got it right. Yep. Hit enter. And our answer comes out to be 1.613 61315. There we go. And so that becomes what our solution happens to be. Okay. So that's what it equals when you get finished with that. Okay. Questions with this one? Again, watching and making sure that you got different bases in here. I could never make 18 match a 6. There's no way to do that. Okay. 6 could never match with whatever I have for 18. So I need to use my logs in there. So this part's not too awfully bad with that one. Okay. Let's see what we can do with this thing. This one's a little bit different because it happens to have 2 things that have x's up above. And so let's see what we can end up doing in taking care of this part. So I can't make 10 and 5 match. If I could, I'd be really good. So then I can really work it out that way. So we're going to do ln's this time. ln 5 2x minus 1 equals ln 10x. So now I need to move this to the front. So I get it out of the way and I get it so that it's in that location. Then I need to distribute it. So I'm going to multiply this by each piece. So I'm going to have 2x ln 5 minus ln 5. So we use a distribution at this point. Then I'm going to get all of my things that have x's together on one side and all of my things that don't have x's to the other side. So I've got to minus this from this side and minus it from this side. And this piece needs to go over to the other side. So what I'm left with is 2x ln 5 minus x ln 10 is equal to ln 5. We good there? Yes or no? You guys think? Okay. Now, let's take my x and pull an x out of each of these. And then, last of all, let me rewrite it up here so I have a little more room. Divide off 2 ln 5 minus ln 10. And then I find that x is equal to ln 5 divided by 2 ln 5 minus ln 10. So then I got to stick that all on my calculator. So when I put it on my calculator to end up solving this, I'm going to go to, no, I'm going to go my top in there. Top piece first, ln 5 divided by parenthesis, because I need this whole thing to work out. I don't need it just to divide it by the ln 5. 2 times ln 5 parenthesis minus ln parenthesis 10. Whoops. Parenthesis, and then close it with a parenthesis because I need the other double in there so I get the whole thing in place. And now if I hit enter, I should end up with my answer. And if I round this answer off to 5 decimal places, 1.7564, the 0 is not going to change to 7, so I get that for my answer. What do you think? Okay or not okay with that one? That one's probably, out of all the stuff we're going to do today, is probably the longest one of everything that we need to do. Again, bases didn't match, but they're in exponential form. So I use a natural log. Now, could we use log? Sure. Log could go in here and we get the exact same answer if you put a log in as opposed to a natural log when you're working this one out. So first, we put that in place, moved our exponent to the front, then distributed. Then we got all our x's on one side and all our non-x's on the other, and then factored out an x, and then divided the whole thing out. So that's our process with this one. So you want to be careful with that one and watch what you got going. Okay, now we're kind of shifting gears a little bit here, where we now have logs involved, and we're no longer just with exponential stuff. We're going in and we're working with our log values. So what do we have? Well, the other day when we were working with these things, remember I told you there's a 10 right there with every log? Every log has a 10 if you don't have a number there. If there's a 6 there, then it's a 6. But normally, if you just have straight log, you've got a 10. So what does this mean? Well, it means that I have 10 to the third power, if I reverse it, is equal to 5x. 10 to the third equals 5x. All we did was turn it back into exponential form, and we did that in 11.2 was where we were bouncing these things back into, not 11.2, 11.3. Get my right section. 11.2 was still working with functions in there. So 11.3. So we said 10 to the third power is equal to 5x. Divide by 5. So I have 10 to the third divided by 5 is going to equal x. So once again on my calculator, 10 caret 3 divided by 5, and I get an answer of x equals 200. So 200 would be what I have with that one. So if you don't have an exponential piece in here, the exponent part, it's 10. 10 to the third is equal to 5x. So then you just divide by 5 and you come up with what your x value would be. This has a log on only one side, okay? That's the key. Log on only one side. We're going to get logs on both sides as we keep working through these. And so I wanted to make sure that we knew that if you got log on one side, that's what we end up with. So this guy looks kind of complicated. Looks like, oh boy, I don't know whether we can get this thing or not. But if I put it back as one log, what does the plus sign mean? We had those the other day. That was in 11.5 was where we did those. We expanded them and then we took them and put them back together. This case, I need to put it back together. So I have log x minus 1 times x minus 4 is equal to 1. And again, because there's only one log, so the log is only on one side, there's a 10. 10 to the first power is equal to x minus 1 times x minus 4. And so now all I need to do is FOIL this side, move my 10 over, and I will be good to solve this. X times x is x squared. It gives me a negative 4 and a negative 1 is negative 5x. Negative 1 times a negative 4 is a plus 4. Move my 10 over. Okay. Then take this piece and factor it. So does it factor? So will that side factor? Negative 6 and a negative 5 is a negative 2 and a negative 3. No. Negative 6 and a positive 1. Let me get it right here. Because I got to get a negative on the end and have a subtraction in the center. Set them both equal to 0. So we get x equals 6 and x equals a minus 3. Well, you have to be careful because I can never have a log be negative. So a negative 3 and a negative 1 gives me a negative 4. Negative 1 and a negative 4 over here gives me a negative 5. So I cannot use negative 3. So if you get doing these and you stick both answers in, that could be what your answer comes up being wrong for. So x equals 6 is the only piece that I can possibly use because I can't have that negative in there with my logs. So, pardon? Oh, it's 1. Yes, it's 1. I want to keep putting that other one in there. Here. X plus 1 equals 0. So it can't be a negative 1 because even a negative 1 plugging it in, it'll be the wrong piece that goes in there. Okay, so I can't have that one in there either. So you want to watch, make sure that you get those pieces and get them in place when you're doing those. So here's another one. Let's see what we can do with this thing. Now this one's a little different because this one has logs on both sides of the equation. So it's not just one side, it's got it on both sides. So let's see what we can do with this thing. So put this back together. So what does that mean if I stick this back together? Well, it means I have log x. Subtraction means division. Okay. Now I had a rule. My rule back here. Let me find it and show you. My rule said if my logs and my bases match, if this piece is the same, then x and y are equal to each other. So notice they're both 10s, so they both matched. Then, since they both match, I can just simply say x over x minus 1 is equal to 3. Okay? And so let's finish this thing out. So, to solve for x, I need to multiply side by the denominator. So these will cancel on this side. Then it gets multiplied by 3 on the other side. 3x minus 3. Get all my x's together. Gives me a negative 2x is equal to a negative 3. Divide by negative 2 and find x is equal to 3/2. So that would be my solution for this one. So x would equal 3/2 when you're done with it. So this is logs on both sides. So if they're on both sides and the logs match each other, then we can just set what their values that's connected to the logs, set those equal to each other and solve from there. So the algebra in here is just still basic algebra. That part hasn't changed at all with that part. So now let's look at what happens to natural logs. Well, if we have natural logs, again, only on one side, so must use exponents. So it's got it on one side only, and every ln has an e down there. So be careful and know that there's an e that's with natural logs, not a 10 like logs, but there's an e in there. So if I put this back together, I have ln x squared minus x minus 6 all over x plus 2 is going to be equal to 2. See if I can cancel some stuff out here. Whenever they give you this, normally what happens is in the top, you can end up factoring it. So it's going to be a 3 and a plus 2. So then those two will cancel out. So I have ln x minus 3 is equal to 2. Put it back into exponential form. E to the second is equal to x minus 3. Add 3 to both sides. And I will find that e squared plus 3 equals x. Now I can get an actual answer for this one because now I can stick it on my calculator and go e second, my ln, second power, plus 3, hit enter, and I find that x is equal to 10.38906 if we round to 5 decimal places. Well, you want to make sure that you plug it in and come up with what your solution would be. So everything we've done in chapter 11 is kind of coming back in this section because we're using our exponential piece, we're using all of our other parts to come up with what our answers would be in there. So again, it's pulling stuff together and seeing what we can end up coming up with for those. So that piece, this solving equations with logarithms, has a bit of different pieces to it as well. So then let's take a look at this one, for instance. And this is the last piece. This is part 4 of our objectives for today. And it's a change of base. With this one, you will start out with this. This kind of looks a little confusing because it's got A and B in here with X's and B's. So it's kind of a confusing way of looking at this whole part. And so we have to be able to break it apart. Well, what happens is you're going to take each piece in here and break it into logs. So what we would end up with this one would be the log of 3.42 over the log of 2. And so you end up having your log base in here of what that happens to be, and you break it apart. First one's on top, the big piece is on top, the little subscript number goes on the bottom, and then we can solve it from there. So now it's like what we had in 11.6, because in 11.6 we solved these using our calculators. And so that's what happens to these. And so what would my answer be with this one? So if I put it on my calculator, I'm going to have log 3.42 parenthesis divided by log 2, and we end up with 1.7730, because the 9 is going to make the other 9 become a 10, and so it carries over. Actually a 4. This is going to be a 4 for my answer to that one. Okay, and so you just kind of take them, and this piece comes 1, this piece becomes the second piece that you got in there. So the x becomes 1, the b becomes the other, and we are good to go with what we've got with those. So let's take a look at this guy. What is it going to become? So once again, it's log the top, the big piece goes on top over the small piece on the bottom, and it becomes what your solution would be for those. And so what would we end up with? So I have log 0.333343 parenthesis divided by log 3 parenthesis. And I get negative 1.00009 would be my solution to that one. Okay. Now again, the difference between these and the other ones we were doing, the other ones all had equals. This, of course, has no equals. It has just a base in here, and it has this number and the 3. Now, will we get the exact same answer if we set it equal to x, and we did 3 to the x power equals this? More than likely, because if we did the cube root of what this happens to be, we would end up getting that solution. So it'll work that way too. So if you happen to see that in that part, that's what could happen to it. And then finally, this last one is the last problem, the varieties that we happen to have. And so let's see what we can do with it. If we've got x, this value, and all we've got is 5x to the 16th, it's again going back to putting a log in front of each piece, bringing my x down in front, and then just going through and working out what we could possibly have with it for a solution. So what does that come out to be if we finish it up? So we're going to divide by log 5. And so these cancel. And it says round to 4 decimal places, so that's what we're going to do in this one. So we're going to go log 16, parenthesis, divided by log 5, parenthesis, and get 1.7227. So that would be my solution to it with working with logs. If you put natural logs in, the same thing happens. Okay, that same piece is going to happen, but instead you're going to just put an ln in front of each of these. And again, that's the piece that you have to do with those. Okay, so that brings us to the review questions that are in here, or the practice problems. Maybe we should just go through and take a look at these and see if we can figure out what we do need to do with them. So if I looked at 4x, or 4 to the x power equals 64, can I make bases be the same? What do you think? 4. 64 is 4 times 4 times 4. So 4 to the x equals 4 to the third. So therefore, x is equal to 3. So we can work that one out pretty easily. This one, different bases. We can never make 10 and 64 look alike. So that's where we need to go. Log 10x equals log 64. From there, put the x out in front. Solve for x by dividing by log 10. And we will get our solution to that one. So if I plugged it into my calculator and put log 64 divided by log 10, and we get a solution, and they don't tell us where to round, so we're going to round to 4. 1.8062. So that would be my solution for that one. Next one, similar kind of thing going on here. Outside of that, we've got this 3x minus 1 up there. So let me get a sheet of paper, because we're probably going to need some extra paper for that one. 3x minus 1 equals 0.1. Do my logs. So log 2, 3x minus 1 equals log 0.1. Move the 3x in front. Distribute. Add log 2 to the other side. And then finally, divide off 3 log 3. To get x all by itself. And then I just need to put this on my calculator. Log 0.1 plus log 2 over 3 log 3. And see what I get for an answer. So that one's kind of got a lot of steps to it too. So you want to be careful and make sure that when you have a larger exponent than just a single value in there, that you distribute before you work your way through it. So log, oops, I gotta put that in parentheses. Parenthesis log 0.1 parenthesis plus log 2 parenthesis divided by parenthesis 3 times log 3 parenthesis. You gotta do double parentheses in there, because if you don't, you're going to have solutions that aren't going to be what you're looking for. So x in this case equals a negative 0.4883 if we round to 4 decimal places. Okay, and this was example 3. Okay, and then example 4. Put my 15 back on top of my x. There's a 10 right here. So I have 10 to the 45.15 equals x to the 15th. This one, I'm not exactly certain why they put this one in there. And I don't know if you'll have one to this extent, But to get x all alone, how do I get it by itself? What would I have to do to get x all alone? So the only way, when we had x squared in here, what did we do? If this was a 2, what did we do? It was x squared. We did the opposite of a square. We did the square root. So in this case, we got to do the 15th root of this side and the 15th root of that side to get x all alone. So when I stick this piece on my calculator, I need to put 15, go to math, down to 5. I had to put my index in first because it doesn't let you put it in afterwards. So the index has to go first, and then put 10 caret 45.15 and hit enter, and you will get your answer. So x equals 1023.2929. Oops. 2929, nope, that's going to be a 3. 1023.2930 if I round to 4 decimal, or yeah, to 4 decimal places. That 9 that's here makes that 9 become a 10, which makes that 2 become a 3. So I got to kind of really round a lot of places in that one. Okay, so that was 4. And then finally the very last one. And that one's similar to the other one that we had. So it's a good idea probably to go through it too. So number 5, ln x squared plus 5x plus 6 minus ln x plus 3 equals 1. Put it all back together. Are we good there, putting it back together? Yes, maybe. Again, subtraction means I got to divide. So then I need a factor. Plus 2 and x plus 3 over x plus 3 equals 1. These guys cancel. So I get that. There's a little e that's right there. So I have e to the first power is equal to x plus 2. Get x all alone, so I'm going to minus 2 from both sides. So I have e minus 2 is equal to x. And so if I solve it and put it on my calculator, I'm going to have second e, or the ln key to get e, to the first power. I need to put a 1 in there because it won't let you just put e, minus 2. And I get 0.7183 is what x equals. Okay. Again, logarithms are manipulating things, and in here we don't really get to see probably the full value of what they do. We're just kind of going through the motions and trying to see what we have that comes up out of these. If you were to continue on with algebra, you'll find more purposes for logarithms than probably what we do in here with that. So we worked all those through, and I had worked them earlier, so I'm just going to leave this up here as well, and we'll put it on the tape. So if you're going through these and you want to see how they're worked out, it's there too. And then let's do the last ones of 4 and 5 and getting those on tape as well so we see what we have. And then here's the answers to those. And so that kind of does everything. We don't have anything new to go over in here. So that was our last section of the whole class. So questions on any of this? Okay. Now let me get this thing shut off.